Right, welcome back to another little video. Today I'm going to be answering a question I got from someone via email. They were asking about how we can create a mask in the world based around an object's position, and specifically if it's a moving object like a character. So let's get started. So we're going to be using a sphere mask, and if we just open up the documentation for sphere mask, it says here it creates a mask value based on a distance calculation. So effectively what it does is it takes these two inputs and it draws a sphere around them, white in the middle, black on the outside, and you've got control for sort of radius and hardness. So I'll just recreate this setup here and we can have a look at how that works, and then we'll explore a bit more. So here we are, object position, camera position, radius and hardness. So what this is going to be doing is going to be taking the object position, which in this case is that point there, and then also the camera position, which is where our viewport is, and effectively just checking the two of them against each other. And then if we're inside that radius, we're going to get a value of white. So as I get closer, you can see that the whole floor there becomes white, and as you get further away from that point, it's black. So not the best example for showing off the sphere, personally. So let's try something a bit different. Well, we can have a world position. So here we're checking these two positions. One is, say, that pivot point, one is our camera. Well, if you want to check it for every pixel, if we change our camera position, change our object position to be world position, now every pixel is going to be checking against where the camera is. Rather than getting close to the pivot, we can just get close to the floor, and we're getting a sphere around there, and we can change the radius, the hardness, and hopefully those parameters make sense. Cool. Right, well, for the sake of not orientation, object position, for the sake of demonstration, if we just swap those back now, so using pixel and then object position, you can see we're getting this sphere, certain radius around the origin of the object. So that's what the sphere mask does. Hopefully that makes sense. Well, what do you want to do in this case? Well, we don't want to use the object position, we want to use a specific vector that we've told it. So player position. Just connect that up. Now this is defaulting to 0. It's going to be basically the same because that's where the origin is of the world. This is now world position. Oh, well, it isn't, it's over there somewhere, but that's world 0. We want to do the player position, don't we? So we could just take this value here, plug it in, minus 750, oops, I could type 390, 390, something like 226, and we can see we're getting that mask around the player. That's cool, that's what we want. As soon as we click play and move off though, that's not a dynamic value, is it? It's static. We're still always going to have this here. So we need to connect something to drive this value. And we're going to do that inside our character blueprint. So if we just go here, edit our blueprint. It is, don't want to do that. Well, the blueprint knows where it is. The character knows where it is. If we go a get actor location, that's the same value as this. It's this position. But this one updates every frame, because obviously our character moves around. And then we need to get a reference to this floor material. Well, currently they don't know about each other, so what we can do is we can create a variable. We call it floor mesh, and it is a static mesh actor reference. And now this, if we make it editable and just compile, select our character. Now down here we've got a parameter that tells us, we can tell the blueprint which mesh we're looking for. So we're just going to select that floor with the eyedropper. You can find it in the list, however you like. And now, floor, we've got a reference to that floor. It's got the material on. We've got the value we want to update it with. So we want to just do is set vector parameter value on materials, and it'll get the right component and things for us. Then, to make sure our name's correct, so player position, copy and paste that into the parameter name there. Is that. So there we are. Now this is going to go through and update this material value with this player position value every frame. Well, not every frame, we haven't told it how often to do it, but for something like this, It wants to be every frame. You could do it every couple of seconds, but you'll see that jumping then. So probably want a nice smooth movement for something like this. Players moving around smoothly. Something like this is going to want to be the same. Not too expensive to do, it's only updating one value. You don't want to do too much on tick, it can get expensive. Suddenly you're doing millions of line traces and collision checks and everything every frame. That's not what you want, but in this case, like I say, it's just updating a single value, single vector. And there we are, we've got our player with his nice sphere mask around him. You see it works in 3D as you get closer and further away, which is pretty cool. Now what happens if I wanted to set it on these walls as well? It's not going to work, is it? I'm going to have to create more references to more things here. Not really what I want to do. It's going to take me ages. So rather than doing it this way, yes, that's fine. Do a different method. And if we go back to our material, rather than using a parameter, this is just a vector parameter, we're going to be use what's called a parameter collection. Okay, fine. I'll just create a new one. The material parameter collection. So what this is, something like player. This is a repository of different parameters. So here we've got player position as a parameter in this material. If I applied it to the wall, that would need to be updated as well. Play it over there. I could apply this in lots of different places, but I all want them to be using the same position. So I want to share this vector between all those materials, and this parameter collection is the way we do that. So we create a parameter here. Say call this player position. Doesn't matter what the defaults are because we're just going to be updating it, so we can leave that at 0. And now, rather than using this vector parameter, we want to use what's called a collection parameter. Here we are. We can tell it which collection to use. NPC player, that's the one I just created, and what parameter name, player position. Now there is a slight problem here. You'll notice here this says float 4. If we connect it up, it says it can't do the maths between a float 3 and a float 4. It's undefined. Well, what's happening here? Well, this is actually, it's an RGBA, isn't it? And we're getting all that RGBA here. When we do a vector parameter, this is also RGBA, but this one, this pin is only RGB. So all we need to do is just mask it down. Now we've got RGB there, which is the same as XYZ, so now we're getting our position and we're comparing them. That alpha channel, the data never gets set anyway, so it doesn't matter. So now, let's compile this. It's going to be looking at 0 there. Hopefully if I update this, you can see that that's working as we expect. Which is pretty cool. So now we need to update our blueprint. So this is actually a really easy thing to do. All we're going to do is set vector parameter value. So this is a different node, different set vector parameter value, and this time it's looking for a collection. So NPC player, player position, every frame, plug this in, oops, and it's going to convert that vector to a linear color for us. And so that's just creating that alpha channel that we don't need, doesn't get used, but here it needs to have the alpha channel, so this just creates it for us, and then we're just ignoring it again there. Cool. So now if we save all these things and make sure everything's compiled, I click play, I get my player character. So it's the exact same result as we had before, but the advantage now, if I've got these wall materials that also have the sphere mask on, they're all sharing that same parameter. I don't need to reference to the floor mesh specifically. I can just reference that material. Cool. Why might we do this? Well, actually creating a mask around a player like this is really useful. You could use it for like fake lighting, interacting with kind of foliage, things like that. So maybe as you brush past it, you get a bit more motion in your wind noise or something like that. Anything you like, really. You could create a force field that a player can walk through that kind of like makes that disappear and then reappear behind them. All sorts of things. Cool. Hopefully that makes sense. As always, if you have any questions or comments, let me know, and I'll see you all next time.